Hi, Franz. Welcome back.
Hi, Adam. Hi, Adam. Third time in a row. Nice one.
Yeah, and you actually, what I found out is that I can just, buy a subscription with you because whatever I would like to know, it turns out you are a committer in the project. So actually, so you're
Yeah,
like generic committer, right? So whatever I have questions regarding Java, I can ping you, and we have a nice chat.
yeah. It's a funny thing because I never noticed that I was so widespread in GitHub, even though my colleague like Ollie Cummins
Hmm.
is making um, a presentation called Quarkus Zero Waste and
Hmm.
Italian Graft something,
Hmm.
in which he basically claim that the work that I'm doing together with other people are one of the secret sauce of Quarkus. But very surprisingly, I'm I'm not a I'm a committer in the Java ecosystem. So in general,
Yeah.
you can find me pretty much everywhere. That is a bit fun because I always complain that I'm not writing as much code as I want. Actually, if you look at my GitHub contribution, are very low. So it's when I was younger, I was
This is
more.
why ChatGPT is working for you, right? So I think what
Exactly.
I think what you are doing, you are just joining a project, then you just reformatting the Java doc, perform some commits, and switch to another one, right?
Exactly. Well,
Just get. Mhm.
yeah, thanks God, ChatGPT is not a training on my code. I hope for the rest of the world because most of the time, what I write for the internal part of a different project could be very ugly in order to be fast.
Yeah,
But it depends.
yeah.
It's a balanced act.
Mhm.
But I tend to seek project in which I know that deliver some special value. And Netty was one of them, and not just Netty. So, for example, I'm one of the maintainer of JC Tools and Netty clearly, and a load generator built by my team, the app service performance team in Red Hat, called HyperFoil. And because of that, there are part of HyperFoil that, in order to be very fast, has been written in a very exotic way, like branchless programming, so a very ancient technique in order
Mhm.
to avoid branches for many different reasons. We had to learn about things like coordinated omission, that is a not so well known term in load generation. But yes, please tell
Last
me.
time, so after our conversation, I wanted to chat with you about Java IO, Java Nio, and Java Nio
Oh,
2.
yeah.
Then you mentioned JC Tools. Then I thought, okay, is an even better idea. Now you mention HyperFoil, which uses JC Tools, and now I'm thinking this is the best idea for now. But I will have to re-invite you back to talk about this Java IO thing because it's interesting, and also JC Tools just for fun. But why I'm so interested in performance or stress generators?
Yeah.
Because I tell you what I'm doing in projects, and this is uncommon, and I get lots of trouble with it. So, in all my projects so far, like okay, history. I already mentioned I used lots of application servers, and I'm a consultant, and similar actually to your tasks, but a little bit on higher level. I was often hired if something didn't work. And if something didn't work, it was actually never that the algorithm was wrong, or maybe I cannot remember, but it always, external systems, IO blocks, memory leaks, garbage collection issues, transactional inconsistencies, stuff like that. And such problems could never be caught by unit tests. But the
Yeah.
companies always ignore that. So what they wanted to have is 100% code coverage with unit tests, which I never understood, and they completely ignored, integration tests. I call them system tests from outside,
Smoke
black box
test.
tests, and
Yeah.
stress tests. And
Yeah.
what I insist on, actually, hopefully is on the slides. I am back from Stockholm from a JFocus conference,
Mhm.
and I had on slide stress tests over system tests over unit tests. So this was on my slides, because if you think about this, so in my world, if we're running Quarkus, what is the worst possible error you can get? Concurrency error, right? So what I would say is we should focus on stress tests first. Then, of course, you will have to implement system tests like black box end-to-end tests. And unit tests, I would say, if you are a reasonable developer and you have complex code, write the unit tests. Never write tests for getters and setters. This is what I did for years, but I always get trouble in larger companies because they would like to have statistics. They actually don't care, this is my feeling, whether the software is working or not. What they would like to have is nice stats, our code is fully tested and have a mark on it. And this is actually my background.
No, it's interesting. I have a couple of guesses why a few companies doesn't like it, even though it's very beneficial. Because as you said, yes, it's terrific, deliver a terrific value. But for companies, the very first problem is to have a measurable SLA they will commit both themselves and their own infrastructure. There are companies in which they have it. Sometimes it is well hidden. So they actually, if you have an interview with those people and you ask, okay, you don't know what's your SLA, let's talk about it. Let's say that the P99 should be below 10 seconds or 100. And they are going to say, oh, come on, 100 is too high. No, let's make it lower. It's probably, we expected 3 seconds. So actually, they have SLO and SLA, but they sometimes doesn't quantify those. And when you quantify those, you can think about what your stress test is going to look like. Because
I don't not even going that far, By the way, for the listeners, SLO is server levels objectives and SLA is service level agreement, right?
Yeah. Exactly. So since when you design a stress test, you can design it to check at which point the system break, or conversely, you would like to allow a smooth experience to your users. So the stress test is aiming both to perform capacity planning, but at the same time to verify that the system under a known load is still capable to delivering a decent experience to user. But decent always start with some threshold in mind.
Exactly.
Because if not, you will look at the number and you will say only when it's terribly bad that something is broken. But if it's not bad, how much you can tell that is decent for your user. And that's required to both gather telemetry out of real production data and try to correlate what happened when the actual experience is getting bad. I can give an example for that, but sadly, it's coming from big companies like, for example, Google.
One, you are too far. So what you are talking about, I think we never achieved that level of maturity. What you are requesting here in normal projects, because what I will happy already, just start our stress tests and try to break the server and see what happens. So this is just fun. I would say generate massive load.
It's useful.
Yeah, and see what happens if we have not enough database connections. How the logs look like. How much memory do we, and is our error handling sufficient? So just basic stuff, and not even this is reached. So this will be the first step to establish a baseline, to have a feeling how fast can we be, how well our application actually scales. It's like playing with the performance, right? And this is already hugely variable and completely ignored.
Yeah, it is actually. But I can tell you more, is even ignored by the people that actually write load generator sometimes. Because in order to achieve that, usually you require some test of some form. You can write by your own self the clients that is actually going to perform that operation. Or you can buy or actually use an open source tool for that. There are many different of these tools, but like 10 years ago, Gil10 discovered, or better, since his company was very tied to deliver timely latencies for its
Gil, you mean from Azul?
Yes.
This is an incredible guy. You had a chat with him
Yeah,
already?
yeah. I know him because I'm one of the contributors for HDR histogram.
Yeah,
So
of
that
course.
is
Yeah, of course.
of course. Why not? Just a single contribution. No, probably 2 or 3. But
Yeah.
But actually, this guy, I know that's. I'm surprised as well. But anyway, this guy talk about a problem of many load generators called coordinated emission. I don't know how much you are familiar with the term, but
No.
if not, I can
Yeah.
explain
Yeah,
even
please.
to users. So basically, in the past, but even now, sadly, load generators that would like to push a load against another system, and they have a schedule in mind for this load. So let's say request per second. So you configure JMeter. Let's say I'm picking a random one, but for good reason. You will see later on. So JMeter, you can configure the rate request per second. What happened? This system, when they have to measure the response time of the server, they actually pick the start time in which they are capable to send the request to the server, and they get the elapsed time when the response come back, and then they measure the elapsed time. Since they have the elapsed time, they can put it into an histogram or even in a database that collect all the data. Is not important. And this kind of methodology, it's broken. And it's so fun because for 20 years, the people always brought load generators like that. And you will think, what's wrong with that? What could be wrong? The problem is being coined under this name, coordinated emission. It's coordination and emission are two different parts that altogether make the quality of the measurement to fall off of a cliff. The coordination happen because let's say that you have a protocol like HTTP, for example, in which unless you are making use of pipelining, usually you have just a single request in flight. So the concurrency by a single connection that you can achieve is always one, basically single message. Now, when you have a stack like an HTTP client that would like to perform a request, and is going to pick the start time when it's capable to do it, you still have another part, a metronome, a ticker, a timer of some kind that try to be stick to the request per second it would expect. But what happens if the server cannot answer in time? Since the protocol is made that you cannot push a new request until you get the previous one done, they are actually hold on until the previous request is completed. So the subsequent request that is going to be sent will pick another start time that is much later than there was actually the scheduled, expected, intended start time. And because of that, what happened? So let's try to figure it out, a mental experiment that was very known in the physics when early centuries, let's say. The mental experiment is, let's have a server and create a garbage collector pause of 10 seconds. And you have one request per second of your load generator. What will happen is that since one of the requests will take 10 seconds to be executed, the load generator one will keep on pushing new requests for 9 seconds, let's say, the whole duration of the pause. When it will do it, it will record as a new start initial time for the one of the requests to be exactly when it's capable of. And in the old samples collected by the client, you will see a single outlier of 10 seconds. Is it fair? The answer is no. It's broken from a statistical perspective. Because from a statistical perspective, since the server was not responsive for 10 seconds, the actual experience of users in that meantime is not to have a single outlier of 10 seconds, but it lose the chance to send other 9 requests. So you should be able to account for that when you look at the percentile, so distribution of the actual latencies and response time of the application. Since we
So
were
what you would
talking
like to
about,
have is like transactional HTTP, where every request is without any buffering and queuing.
no, it's much simpler actually.
Okay.
It's so simple that the people, when look at how it is solved, they go nuts and say, "What if it could be that simple?" It is. Basically, since you have a schedule, because you have the request per seconds, you can actually pick not the start time when you're able to send a request, but the intended start time. That is a computed value. And if you are using that one to account for the actual duration of the response time, from a statistical perspective,
How it is computed?
It depends on what kind of function of scheduling you're going to use. So if it's a constant rate, it will be like following basically a line. And then if it's a Poisson one, you
so
can
you have virtual
compute
clock which pre-calculates the timestamps, and they are associated with the timestamps, right?
Exactly. You try hard to be stick to it, but if you can't, when it will happen, you have to account for the wait time in which you were not able to send any request. And that thing is solving the coordinated omission problem. So basically now you are accounting for the bad experience. You will see that the P99, so the 99% of your requests are actually very bad and not good anymore. And then in that case, you can literally know if your server was actually good or not good for your users. Because if you think about like the Google, no, the homepage of Google. Homepage of Google could perform like 9 parallel different requests. No? And this request, the slower one of this request is the one that dominates the user experience, because maybe is the one that doesn't make you to see a part of that homepage. When this is going to happen, and the user perceive a slowness, can keep on calling a refresh. Basically, it's stuck. It's bored by it, and it will run away, very likely. And since modern home pages doesn't have a single request, but in order to be delivered, can perform n different requests, the chance that you can perceive the 99 of the latency of the worst latency of your system is much higher than the 1% that you would expect. Is much more. You can have the 30% of your user that will perceive actually that bad experience with the home page. So measuring it right with the client and the load generator is very important to have a realistic view of the bad experience that your system can deliver. But this is going to be a very troublesome kind of fix, because the most of the system that were using bad load generator were not able to see that. So the life of the developers working on the backend stuff was, I make a very good job here.
Yeah.
Why should I know that it's worse? And that's the problem. So it's very useful for companies, very bad for developers.
So for understanding, so we have the virtual clock, and the tasks try to keep with the clock. If they cannot, there is a hole, and the hole will be reported as failure. And back then, the load generators used queuing. So what could happen? The server is not available for 10 seconds. It was not recognized, and all actions were queued. And after 10 seconds, maybe one was timeout, and all others were sent after 10 seconds, which was actually a failure. But if the server was elastic enough, everything was successful, right?
Exactly. And even nowadays, there are very known load generator, and I have no problem to tell name of which one. JMeter is one of them. It's broken. Another one is K6. So if you are using a Kubernetes kind of load generator like K6, it drops silently the request. It cannot be.
But you are lamenting on high level, I would say, right? Because what you try to be perfect.
Oh, better. I would like to capture when something is broken.
Yeah, no, yeah, exactly. Yeah. But I tell you an interesting error from one of my projects. So for me, the main problem is to generate enough load first, to saturate the server. This is a real problem. So how to do that from developer machine, from where? So this is the first problem you have. But if you achieve that, so what we found once is we had an application server back then with incoming queue, and there were requests in the queue, right? And we generated that much load. Actually, it happened in production, but we could reproduce it then in stress tests. That if the queue was deep enough, the youngest requests had no chance to be successful because the latency was higher than the timeout. So whatever the server did, it just processed timed out events, And this was interesting part. So I think I would like to uncover such problems. And so I don't actually care whether JMeter measures something correctly or not, because usually we don't even look at the results from the generator perspective. We look at the metrics of the application server and say, hey, are you stable? What is the memory stable? If the load goes down, are you recover or not? So this is the interesting parts. And what you are reporting is more like user acceptance tests, which are troublesome, from different perspective. What I saw in larger companies, what they did, they said, okay, we have 5 users in enterprise who will interact with the server concurrently, use nothing. But in enterprise, sometimes it is like it is, right? If there is a department of 5 people, you have 5 people. So, and then they thought, okay, the user clicks something and thinks, and they had think time in the load generator. So it means basically, I observed the server, there was zero concurrency. It means the load tests, it measured the perceived user experience, but there was exactly zero load on the application server. And then I started, to say, okay, I don't care what the companies are measuring with user experience tests. We have to generate brutal load and see whether the server is stable, to uncover programmer errors, statics, cache concurrent modification error in hash maps. This is what I would like to see, right?
But think about that part. So let's say you would like to have a no loud throughput kind of test.
Mm-hmm.
Still, if the load generator coordinate with your system, you won't be able to keep on pushing the load. That's the problem. Yeah. Because since the request is not completed, no new one will be created. So when the load generator should do it right, what it should do is to create a pool of connection and treat every single connection is the most granular, lower level of concurrency. If one connection is not available to produce the load that is expected to produce, a new connection will be picked and will be sent. And if it's not available, another one, until the number of connections is sufficient to basically bring down the whole server. So the idea is that even if you do it, the all-out throughput test, the load generator problem is always to do it right, to not coordinate.
Yeah, you are right.
With your
You're
system.
Right. Yeah, right. No. But I just wanted to explain, your take and my take. So and what you are explaining, this would be afterwards, right? So it's okay. Our server is stable, user is happy, and now do it right. Define SLOs and SLAs and see what we can expect. This would be, the most valuable thing. But what you are saying is that I didn't know that JMeter doesn't pull the connections; it just creates the connections on the fly.
No, it could pull it, but the problem is that it don't treat the connection as a virtual user that should enter, perform a service in an independent way. But it just throw as many threads it could, and the number of threads basically dominate the ability of pushing the load. And that means that since you are tied with physical threads, you risk to have usually you tend to have, if you want to create a stress test, the server that is using, let's say, half of a machine, but the client should be way more. But the problem is that with the JMeter, this ratio is bad, since it has to create a new thread in order to push an entire new load for a single user. And that's not great, even if you're using Loom. In that case, you are not having a platform thread to actually emulate the presence of a user that is going to perform a request. But still, you are tied to not pick what you want, but is in this case is decided by the Loom scheduler which thread is going to be performed the load, and you don't know if someone was stuck in the queue of Loom, and that's the virtual thread Loom. So that's one of the problem. The other problem, and is relevant, is that usually JMeter and similar tools never go that far to rewrite the client protocol. I can give an example for that. In HyperFoil, and beware, I'm not the one that wrote it. So there was a colleague of mine that now works in Azul, that he was a brilliant engineer, is still alive, is a brilliant engineer, is Radim Vansa. It worked for Jill, actually. And this guy looked at how the NetT client, the HTTP protocol, was implemented, and he created a partial state machine on the client for the stress test of the HTTP side. In that way, you can use a very tiny machine with one core, and you can bring down an entire server using NetT on the other side. Because the way by which has been implemented is to be super cheap, the load generator. So cheap that actually is cheating. It's not even implementing the full HTTP protocol, but who cares? Because the whole point was actually to be able, with very tiny resources, to be able to push some stress on the other side. And it was a very complex decision from development perspective and maintenance perspective, because it means that you cannot rely on the client provided by other tooling. But at the
Why
same
you
time,
cannot rely on Java HTTP clients? Why you have to rewrite the protocol by yourself? I didn't understood this.
Because of the way by which is there are two things that are very bad with the Java protocol, HTTP protocol implemented. One is that the people should stop using a switch to implement a protocol based on RFC. That thing doesn't work well. It works well just in benchmark, because sadly switches introduce branches. Branches, when you have a flow of a stream of bytes, unless are very predictable, it's very unlikely that you will perform as good as you really believe. And that's one of the problems. The other problem is inherent of the tool itself. The HTTP client of Java is a complete HTTP client. So it actually not emulating what a client would do, is a client. While for HyperFoil, it's different. It emulates a client. So there are parts of the protocol that are not even implemented, because are not required, because are not exposed in order to be modified. So
then the question, what is HyperFoil?
HyperFoil is actually a coordination omission-free, both simulator and stress load generator. So you can actually stress the other system, or you can create through a DSL or YAML an actual emulation of what the users will do, and you can push very hard on the other side the server. And he's actually implementing few, as I said, partially implement HTTP 1.1, HTTP 2 as required in order to be very cheap, and is distributed. So so many people ask me why you didn't use Gatling, because Gatling is actually solving exactly the same problem. And I know Landell, so the actual developer of Gatling, is a good friend of mine, because he is one of the other developers of NetT. So he's very skilled, but clearly it's a company. It has to sell a product. So the distributed version of Gatling, you must pay for that.
And this is, I think, written in Scala, so you get a lot of dependency.
And it's written in Scala. Yeah. So in the case of HyperFoil, since we couldn't buy a subscription for Gatling distributed, my team decided, okay, we are skilled enough to do it ourselves. So basically, it's able to be distributed as well. And since the authors, that was Radim Vansa, was very good in statistics, it creates something very special in this regard. So we have a test that performed the Cosmogore of distance in order to make sure that the actual Poisson distribution is working correctly. There are not many load generators that go that far. I won't say it's the best, because there is no best. Everything should suit a different peculiar task. But since we use it HyperFoil internally for a lot of stuff, including RHEL testing or native backends, Istio, literally we use it pretty much everywhere in Red Hat, it's working very well, and it's actually very cheap in terms of resources. He pushed it a bit too far in some regard, because this guy decided to make a GC almost free kind of load generator that is pretty unique and look like what HFT does. So he pre-allocate pretty much everything from the beginning. So there is nearly no GC activity.
How
And
much
then-
load can you generate with a single instance? So what do you know? So no, what is the highest load you generated?
Since it's completely non-blocking, I don't know. Because with the Netty, we arrive to have a 64 core Netty instance, so very low level, or even Quarkus actually. And we were still limited by the server, not the client. So we were able to have 190% utilization of the server just by using a single HyperFoil instance with the 2 cores. So 2 cores versus 64. I think it's pay off, the decision to be very strict into both the GC and no, it's definitely very good in that regard. Maybe the people doesn't need that much, and that is another point. But since it's free, that is another good selling point, I would say.
What I used for my basic tests was Apache Benchmark, AB. But just, to have high load and just to see what happens. So it is on every Mac, but the interesting part, it is broken. I forgot, but it is broken that way that it actually stops working. So it's not like it doesn't measure incorrectly, and there's a replacement for it. And what I used is a tool written, I think, in Go, something with V, forgot the name, I will remember that. And this was AB, they refactored AB, and it generated enough load that I could break my servers. But what's interesting is I never found HyperFoil, actually. I would use HyperFoil, but I didn't know about that. So I learned from you right now. I took a look at the project page and GitHub page. And what's really interesting is, or unusual even, you can configure the thing with YAML, which I would say unusual, but it's okay. I mean,
I can tell you why.
Yeah.
I mean, as I say, there is a good story of dog fooding from my company. So my team actually is very good in this regard, because we have 3 tools we made. One is HyperFoil. The other is called QDAP.
What is this?
QDUP. It's interesting. If I have to follow the definition of few of my mates, is a shell on steroids.
Wow.
Because basically, when you perform a stress test, there are certain phases and practices that hold regardless. And sometimes, since you have a Jenkins CI of some type, you have to learn how to integrate with Jenkins and so. QDAP solve all this problem, because it makes what you will do manually to be performed by Bash, which throw SSH against the server. So the actual server doesn't have any code. It's doing the same thing that you will do manually. So it enter in SSH on a server. It allows to have a parameterized kind of execution, in which the stages of execution looks like what you will do when you do things right in Jenkins. So you have a setup phase, you have an actual execution of experiment phase, and a cleanup phase. And it's nothing more. It's a very thin layer to avoid knowing Jenkins and still be able to run things locally or on Jenkins without noticing.
It's like a shell automation tool?
Kind of, yes.
Okay.
And it's still with the YAML. But if you have a Bash script...
Written in Java?
It's written in Java.
So amazing.
Actually, yeah, and it's pretty invisible to the user, because for the user, they have a Bash script. They can take their Bash script line by line, make it a QDAP script without adding abstraction, because it is, as I said, it is a shell at steroid, literally. And you have basically a test in which you can make it parametric and run on Jenkins without even notice that in Jenkins. You can even perform a distributed test in which you can have a different host in your QDAP script.
Then QDAP is something like shell in Java, as Java process.
It is a shell plus SSH, but a declarative. So you actually have a script in which that script is going to be executed or locally
But
or
the
in
QDAP is a
machine.
jar, so I would have to execute the jar and
It's a
give it a
jar.
shell.
It's a
So
jar.
so
Exactly.
I could write a Maven plugin, for instance, right, which uses QDAP to execute shell commands, right? This would be
Exactly.
okay. Now I
Exactly.
got it.
So, and QDAP is one of the other tools. The other tool is called Orium, and Orium is a change point detection platform storage. So it means that the most of our project in Redact benefit from having a nightly regression performance test, and all these data and the automation and the algorithm to detect if there is a point in which the performance has changed according to specific metrics is managed by this Horium. So HyperFoil is one of the three tools made by my team, and everything is used a lot in Red Hat. So we have
So
a lot
Horio
of
is like
internal customers.
a diff for performance results, right?
It's for performance results, exactly. And it's both storing, adding change point detection, cutting edge, different algorithm coming
So
from
it
the
understands
literature.
HyperFoil output.
It can understand many different YAML, JSON kind of output, and have a transformer, so you can create is a schemaless. So you can add your schema in order to interpret the way by which you save your data, and it will transform it in a way that can understand the metrics and applies the actual algorithm to detect if there is a change in performance. And it can notify you back via GitHub, Slack, email. So what you will do when you set up the whole chain, so you have HyperFoil that creates the load generation. The load generation is using QDAP in order to running on Jenkins, and QDAP can upload it to Orium, and when it happens, you can receive an email that there was a commit X, the performance of a specific metrics, RSS, let's say, has changed. And so we have all this automation in place for Quarkus, for example. So my work as a performance engineer is to solve a regression when it happens. But since it is very tight, it's happening every night, it's very easy. I don't even have to perform bisect most of the time to find the culprit of the commit. I know already what's the commit, and I can just rerun the same.
How it's pronounced?
The same thing.
Horium. HOR.
Horium. HORREUM.
Okay. Double R.
And the funny
So it
thing
also
is you
knows
can
about
enable
commits, the Horium
profiling.
thing.
Yeah, I mean, Orium, as said, is another piece of the puzzle. And returning back to HyperFoil, because they are very tied, all of these tools are made to be used by a very different type of users.
It's this ancient Roman house, right? Warehouse. Is it the...
Yeah.
Okay, cool. So a cool name. And the names are great. HyperFoil I like the most so far.
Yeah, HyperFoil is interesting. But
name, the name is great.
The name is important.
The name is very important, but it's very good for a performance test.
And as we say, that you were surprised about YAML, so the fact that is declarative. But the reason is because some of the internal users in Red Hat are QEs. So not all the users are expert users that can write code. There are users that would just look at a YAML and just deploy something that, according to some language, allows them to just tune or change a few parameters and run different tests. So we made all these tools having very different type of audience in mind. Developers, QEs, normal users that care about the UI experience. So they don't even want to know about Java. It's not important that is in Java. It's just important for us because we can leverage a few of the building blocks we were used to. And one of them is JC2, actually. So JC2 is extensively used in Orium and not in Orium, in HyperFoil and in Netty, clearly. But it's still a bit.
So how to configure then? Let's say I have a simple use case. What I would like to do is with post, I would like to create, let's say, entries, articles, and with get, I would like to see the article. So this is like a combo: post get and delete, maybe post get delete.
Yeah.
So how to configure HyperFoil to do that? So what I will have to do? Hmm.
In there are a couple of quick starts published by Radim
Hmm.
on Medium,
Hmm.
and one of them is very similar. So basically, what you will do is you have a YAML in which you configure what's the server you have to push
Hmm.
the load against, and you basically decide for different sequence of action that should be performed. So actually, you have a sequence like
Hmm.
the name in the YAML, and through sequence you can leverage pre-existing building blocks that make you very similar to actual language. So you can perform a random CSV input peak of different value. So you would
Wow.
like
So
to
so you can
populate.
even randomize inputs. It's also done by
Yes,
HyperFoil?
yes, and you can have a very different distribution in case you have a specific distribution, or you can pick it from a file that you will provide. So together with the test, you provide a file of all the possible type of input that you would like to perform. You can use one of the action that is called the random CSV something. Is going to pick a specific value. You can transform that value or just use it as it is, compose an HTTP request, and have a different handler that with a subsequent action of what will happen later on. So other action, for example, are to store the response into an array, and then you iterate. So you have a for each action that iterate through the array to perform other requests or add a think time. So has been made to solve a real problem in my company.
So
So
you
the
could
most of the
also
build.
use JSON directly as input?
Yes,
Okay.
yes, exactly. And the funny thing is that the people say, why is that complex? Why there are so many action? Because we need it. So nothing there has been made just for to say how happy was the developer to write them. They are coming from actual requests internal in the company. So they are tested, they are used, and they usually work. But it's software, so bugs still exist. But the fact that you have this amount of feature are coming from actually requests from user to create or simulation or normal stress test. And since we want even a normal user that don't care about the simulation, they just wanted to push some load, we create the WRK wrappers in which you can use a WRK like syntax that is a one-liner basically, and you can use a JBang for that. So you will write a JBang HyperFoil at WRK, and with a single liner, you get all the engine of HyperFoil to behave like a WRK. It just push a single load against a specific
Now Max is
endpoint.
happy we mentioned JBank.
Yes, yes. JBang, actually, Max helped a lot because having the integration with JBang was good because since the people that would like to use such a tool have a very high barrier to start with it. In a company, you won't feel it because the people just receive this tool and someone, maybe a manager or a boss, say you gotta use it.
Mhm.
So you don't like it, you still have to use it.
Mhm.
And that doesn't help to get good feedback if something is unless it's broken.
Mhm.
If something is not so good, you risk to suffer from the so-called survivorship bias, in which the people survive to the kind of bad feature you implemented and they just accept them, including the bugs or bad ergonomics. But since we want to expose it even externally, the JBang integration was very good because the people can use it with a one-liner. You just need to have a JBang installed, and you can just use
Mhm.
WRK or WRK2 with a one-liner with HyperFoil, and it
Mhm.
just works.
What I used in the past also, it was called Vegeta. You know what it is?
Yeah, I know it.
Vegeta. This is
Yeah.
was but just to generate load. I didn't care actually, and with that I was able to break servers. AB was too bad, so back then Quarkus and Whitefly and Glassfish were too fast for AB. So AB was couldn't generate enough load. AB is Apache benchmark. Vegeta is
Yeah, I
old.
know it.
Yeah, Vegeta is old, really old. So it was like this. I used it before pandemic actually,
And let me
and
send it on the chat. This one before I forgot. So this one is the JBang catalog for HyperFoil.
mhm,
If someone would like to try it, it's a single liner actually.
mhm. Um, yeah, and the the architecture of HyperFoil. This is what interests me.
It's
So because
super
we should, well, I'm thinking as entire time. This is why my garbage collection is running. Like this is why my pauses, right? Because I'm thinking
Yep.
about the HTTP client and partial implementation of the HTTP protocol. What you say? Why you have to
Yeah,
rewrite the
it's a
protocol?
bit crazy.
No,
Yeah,
but like explain me. Maybe then it's a
the
yes or no.
architecture.
So if I implement a parts of the HTTP protocol, so what I can do is I could, for instance, initiate the request and don't care about what happens afterwards. So I can generate more load. Otherwise, I will be forced to, I don't know, to conform to the protocol by waiting or whatever for other stuff which doesn't matter for the load test, right? Is this the
Yeah,
reason?
yeah, exactly. And it's kind of dynamic.
Mm-hmm.
I mean, that's why it's not so easy to be maintained. And that's why I was decent in that, because I knew Netty. So I actually work for
And assembly
le-
behind Meti. So this is.
and assembly. So that helped as well. But I'm not as good to read the RFC. So probably, definitely, Radim was more as a doer if compared to me. I'm very good to make things faster. I learn with the years that I'm not good to start from scratch project and do it right. I've never been good in that. Probably didn't do it enough, I think.
So you are the Apple guy, right? So never start,
Kind, yeah,
always
kind.
improve.
I know that. I know that's. It took me a few years to accept this thing, because I started to think, okay, maybe I'm not good at developing code. Depends. I mean, if it's a matter to make it incredibly fast and learn incredibly complex architecture that the people just forgot how they work, I'm very good. As I told you, I break video cards. I literally very good to understand how things work in order to make it better. But I never be good to start creating something that was good from the beginning. And that thing turned out to be good, because HyperFoil is incredibly complex inside, incredibly. But what it does
Does it
is
have comes with lots of dependencies or just a few dependencies
no
too?
zero dependency. That's the crazy part. So this guy pretty much implement everything from scratch in order to be fast.
I like
Much,
this guy already. So I would say
it's a bit crazy. I mean, but definitely it was worthwhile, because it turned out that since we deploy agent with HyperFoil that can have just a single core, JVM with a single core is not a thing nowadays. If you try to do it, unless there is very few loads, it's very unexpected that it will be well performed. But HyperFoil performed well. And that's the crazy bit. But the attention to the detail was nuts. So, for example, HyperFoil.
Tell me about the basic architecture. There's a front end which understands, the DSLs, the YAML,
exactly.
and the configuration.
With the DSL, there is a parsing phase, which is going to create the graph of object that represent the actual simulation, so the actual benchmark. So you basically have your YAML, and you parse the YAML in order to create the actual benchmark definition that through reflection install a different node of a giant graph that is going to be executed at runtime. So it's like compiling for a language. The same thing, but dynamically. So you have all the nodes that can execute things at runtime. And there is the notion of the very basic notion of a thing called the session. The section is actually the virtual users. And the virtual user have resources and a different of other things that could be useful to each node of this giant graph when it comes to execute these nodes. And the funny thing is that one of the choices of Radim was to implement everything in order to be pre-allocated from the beginning. So you have a pre-allocation of this session in order to satisfy all the requirement of the different nodes they are going to require it. And when you have the actual model generation that create the load, that could be the rate, constant rate, ramp up, different way in which you can execute the subsequent tree of action in a timely manner. When it happens, it has to acquire a virtual user in order to do it. And when it's not capable to acquire a virtual user, this is going to be recorded. So you are in control of any lack of resource that the system cannot use because it's not allocated or because it's used somewhere. So from the perspective of the user, you know when you are not giving enough resources to achieve something, and you know which things to change in order to do it. And the other good thing is that at steady state, basically it doesn't allocate, because everything is pre-allocated from the beginning. So you size your machine, you have requirements in terms of memory, and it will rarely grow up. I measure like 1 GC for 1 hour.
How you manage
data
sockets? So what
generation.
kind of sockets are there, and how it interacts with the outside
It
world?
uses NetI. The underlying structure is using event loops with NetI, but raw NetI. So it means that it is using the basic layers of NetI. So it means
Do you have one dependency is netty?
exactly. They even and JC tools.
Uh-huh.
And NetI itself is event loop based. So you have an event loop that can execute the different nodes of the simulation and have its own not distribution, have its own way to follow the different nodes in order to guarantee fair execution to each of the nodes. So it has a scheduler, like you have in a CPU. It's
Because
crazy.
last time we said if we have the what was the Linux IO paradigm? I forgot the name.
IOU ring.
IOU ring, exactly. And this
Right now it doesn't use it.
I know,
It's
but what
using
you talked
APOL.
yesterday last time that with the event loop, there's requests and you have to wait for the response, right? In order to be efficient. Or you get notified. You get notified about the response. Notified, but you have to match the request to response. And this is why we need the event loop to be efficient. And you say now fairness. It means, of course, because if you send the request first here, then you also have to match the response first there, right? This is
exactly
okay.
Because everything is managed in a sort of queues, let's say. But in what Radim decided is that in order to guarantee fair execution to each node of a graph of a simulation, they are not following the rules of being picked from a queue. So they have a different way to be followed, the different nodes of the simulation, in order to guarantee that it is consistent but still fair with each of the nodes. And it's interesting because that part is so much complex that I never change it. It works, is explained. So the actual scheduling algorithm is coming from a paper that Radim read, and basically is in control of a lot of things that usually load generator doesn't care. And the reason for that is because it's an event loop. So it didn't want to make it biased around a specific pattern of a simulation, because when you start to have a long chain of action one after the other and you are not fair, you risk to delay another request just because everything is managed FIFO or not.
This reminds me, years ago there was a Sun around, and they had a paper about the algorithms within the load balancer. You know, this was like 100 levels up from this what I'm talking about. And what turned out is that the worst possible scheduler is round robin. And there was and they actually explained the reason, which was interesting, is that the first server is always, it has the highest load, and because of, and the best one is random actually algorithm. So and in one project it would be fun for you, or maybe already I try to be smart in load balancers and say, what if we actually learn about the CPU utilization and use it for load balancing, and then we get bouncing, right? So it was like, almost like a sinus curve, exactly.
No, that I mean, as I said, almost of the practice, both coming from statistic, there are a few ones coming from another field that is, there is a law called the Universal Scalability Law. This is a law made by Neil Gunter. Gunter basically created this big equation that explain how make system to scale correctly. And there are a few factors in this equation that give you hints of what could be the good load balancing kind of practices. So, for example, load balancing is a decision, basically. No, is a decision that you can perform in order to perceive a specific action. But you let's say that you have a graph of different nodes of server to pick with. What's the problem? The problem is that in order to reach consensus, in order to decide how to proceed, you should gather information from all these nodes. But if you do it, the time to get this information could exceed the time by which you would like to perform, how fast you would like to perform this decision and still be fair from a statistical perspective. So, based on the law he made, Meta create an algorithm for its internal server for load balancing called pick2. Pick2 is interesting because basically it picks two at random.
Okay.
And it basically just works because since you can have one on the server to decide to load balance, the cost to reach out any of them will exceed by far the time you get in order to perform the operation you have to perform. Clearly, it depends by the type of task you have to perform. Is a very slow task, maybe is not important. But if you have to perform quickly a decision, you would like to bound the number of nodes in order to perform the decision. In the universal scalability law, this thing is called coherency cost.
Almost locality principle, similar.
Very similar. And the coherency cost, it depends by the amount of edge of a graph. So if you have n nodes, you know that is quadratic. So the factor by which you will have diminishing return in terms of ability of increasing your load, get a diminishing return that is based on the quadratic cost of the decision in order to achieve the consensus, because you have to make everyone happy with your decision. And that is interesting because you can take the same law and applies to team and humans as well. How much is good to have so many synchronous points of decision because of agile? It's the same thing. You have n element that are the element of your team, and you have to reach consensus. How much is good to have a sync? It's quadratic, the cost. You will be able to scale because of that. No, if you make it too frequently. So this kind of rule, there is a good reason why it's been named universal scalability law, because can be applied even outside of the computer science field. It's just reaching consensus in order to perform a decision that should scale. And internally, in HyperFoil, we use that one, for example. So since we have to pick the virtual users, we have some virtual users that are local to an event loop and other virtual users that are local to other event loop. The reason for that is because of the model of Netty. Netty is event loop based, so it try hard to be as single-threaded as possible. So you have a fair distribution of virtual user among event loop. But when you exhaust your local one, you have to pick another one from another event loop. How you decide for that? We decided for the pick2 random because we read the paper of those people. And when we switched to another model, it mattered. So since the type of users we have...
So you're picking random two connections on HTTP level, and the paper was about servers. This was the funny part, right?
Yes.
Yeah.
And still it matters when you have too high load, because the real beauty or problem of HyperFoil is that we have internal user that use it for telco. So we are talking about user that send millions of requests per second. It's not used just for...
This is one of the... I wanted to have a number for HyperFoil, and you are saying millions requests per second are possible with HyperFoil.
It scales linearly. So you basically can add new cores and it's going to scale linearly because the amount of coordination has been peaked at minimum.
Does HyperFoil works as a distributed load generator or on one machine?
Yes, one machine and distributed. So the distribution is handled by Vertex, but and the J group. But it's not something that...
Wow, J group's another interesting part, right?
Yeah, it's unknown. I mean, it's hidden in because it's using the distributed part of Vertex in order to have distributed controllers and agents. but it's for free, so it's there. The funny thing is that most of the time the people start with the distributed load because they think they need more threads, and they eventually decided, okay, I noticed that just one is enough.
Yeah,
So
this is
with
wanted to ask. I think one machine. How much can you achieve on one machine? So if there's you have really
depends by the frequency, the type of action.
transactions per
Because
second is always what impresses me.
yes, I mean it depends what you have to do. If it's a single HTTP request, as I said, with the two cores, we
Yeah.
were able to saturate 64 machines. So it was 18 millions of HTTP requests per second. So
On
with
one
two
machine,
cores, one machine with two cores. So it depends what you have to do.
18 million transactions per second on one machine on 2 cores with Java and France.
Yeah. No, not France, Radim.
Radim.
My work, exactly. I won't ever take, the merits of it. Because as I said, I could work in order to make it better, definitely. Better under certain definition of better, faster, let's say. But if it comes to start from scratch that stuff, I would say that I was just fascinated and impressed when I read it. I say, wow, I would never be able to do something like that. Really? I mean, wow. And no, it's good. It's nice.
So it's incredible, really incredible. What's coming. Next time we have to talk about JC tools, because JC tools is, I think, the collection behind or the structures, data structures, not collections, data structures behind the management of the connections. So maybe one question: if there is no JC tools and you will have to use stock Java data structures, I don't know how much slower would it be? What is the impact of JC tools on scalability of HyperFoil as an estimate? Very rough estimate. Just
in the case of HyperFoil, if that part about picking the right session will be the bottleneck, it could be even 10 times lower.
Okay.
But it should be the bottleneck as usual.
Yeah.
If for some reason the server does a lot of other stuff, there won't be a problem. But the good thing about JC tools is not the performance itself, but the fact that it could be GC free in the steady state.
Okay.
While pretty much all the algorithm developed for the JDK are using nodes. So they actually allocate always. So you have a concurrent linked DQ, is going to use nodes. So you allocate for the nodes. If you are using the link and transferred one, still the same. If you are using the array blocking one, you have a hidden linked list there. Even if it's not linked, that is actually the list of waiters in case you have contention, because it's going to use reentrant locks for head and tail. And the same happened with the linked blocking queue. Linked blocking queue is using two separate reentrant lock for the head and the tail. So if you have a contention, you allocate. And it's something that the people maybe doesn't care for that project, but if you want to be GC free,
okay,
yes, you can.
Okay, cool.
So JC tools basically avoid that one, because the basic layers, unless you use one linked queue that we have it, but it's a beauty from the algorithm perspective, but it's still not great because it has to allocate the nodes. All the other queues work in chunks of arrays. So they reuse those chunks as much as possible, or they just have a single chunk. So they are fixed at the sides.
Okay.
And this is something very peculiar of JC tools. And it's something that is not matter of performance, it's a requirement. You don't have to allocate 2 gigabytes of nodes per second, because when you start to approach million of operation per second, you allocate gigabytes of.
Yeah, you are right. This is complete different scale. So this is exactly. Yeah, thank you. It was a blast, and I never had HyperFoil on the horizon. So this was an unexpected episode about HyperFoil. I hope we covered a lot, and I will actually use it. So I always because I always searching for new. As I said, I use the Vegeta one because AB didn't work for me, and I will try HyperFoil because now I think I found the best solution. Pure Java, easy to install for me, and I can generate enough load to break my Quarkus, hopefully.
Yeah, consider that like anything, it should be a balanced trade-off. So there are two. I mean, since I'm not the one that designed it, I see a few pros, and there are a couple of cons and drawbacks of it. Two drawbacks, I think, that one is something that I could improve, and the other not really. One is the ergonomics. So it's made to be usable and simple to do the most of the task that has been designed to be used for within Red Hat. But clearly, we cannot cover all use cases. So maybe the way in which you will use it, you will find out that it throws so many errors. Literally, because if you don't configure it enough, virtual user, it will complain. If you want to use enough connection, it will complain because it say, I wanted to push more loads, but since you have configured too few connections, I can't. And it will complain about it. It could be a good thing or a bad thing.
Okay.
For users that just want it to work, it could be, oh gosh, he's asking too many things to me. And that could be annoying.
Okay.
But there is always a good reason for that. So I'm not saying it's right. I'm saying that it depends by what are your requirements from the tool. And the second one is coming from the just-in-time. So the big problem of HyperFoil is that even if you push very hard in order to be very sympathetic with the just-in-time, the compiler, because it's simple, the code is even quick to compile. But the reality is that if you have a very few resources and you are creating a workload in which you have a ramp up and then a constant load, the ramp up class and the constant load class are two separate threads, two separate classes in HyperFoil. So what happened? During the ramp up, you are warming up that method that is performing the ramp up computation. When you switch class and you use the constant parent, is a whole new class. So the just-in-time require about 10K, 5K, depends, number of invocation of that methods, because it's going to be compiled at C2 level. Maybe your requirements in terms of latency will make it important. But if you have, and we have users that have like sub-milliseconds kind of requirements, when we are sub-milliseconds, you will perceive the hiccups of a method that is going to be compiled in HyperFoil. And when it happens, it means that you cannot trust that much, that amount of time in which the method was still not hot enough. I know that sounds, not that important for most of the users, but as I said, we have internal customers that really care to the microseconds level. And if you get there, you can feel it. How to avoid it? The future looks brighter. So we can make use of native image. That is not the best peak performance, but have no compiler. You can make use of later.
Yeah, exactly. This is actually for you is perfect because you get predictable performance all the time from.
Exactly. And we pre-allocate everything from the beginning. So we don't care about the serial GC or
you're right.
community edition. So it could be a good solution, but we perform some reflection at the beginning.
And so we will make Max sad because we don't need JBang anymore, right?
Well, I wish we will keep on using JBang, at least to attract users, because it's very nice to have a one-liner. Even myself, I enjoy it because downloading the jar and make it start. You have the CLI. With the CLI, you have to feed your benchmark. A one-liner rulable. So if you have to
I also enjoy it, but my point is it should be part of Java.
Yes.
This is it. I don't like the fact that it's external tool. This is the only thing which I don't like about JBang. Okay.
There is a thing. Then we can call it. So, but I discovered that Max is not a Java champion. And I'm surprised because I think that what he did is for the community. It's awesome because there was no other.
I'm also surprised because he should be one of.
Sure. Yes, I think so. I will probably after this call, I will probably to reach out because I think that is exactly what the J champion should be.
Absolutely,
it's awesome. And yes, you're right. Probably should be better if we would be within the JDK because it's so useful and easy to try things. That
this should be a part of JDK. This is why my thinking is if I do something, I just try to use Java, nothing else. And then I don't have to justify larger companies. We need this dependency on this and whatever, right? Because if you leave the path, it's just, hell on earth. So you have to discuss everything. So, but if you just use core Java, we just use it
so
and
much
done.
easier.
Yeah, exactly. Where people can find you? Forked France everywhere. This is what I learned.
Yeah. You can blame me for every bad patch that I send across the world.
No, the more we speak, the more I uncover. The more project to talk. So at least 2 sessions this year. One JC tools and of course IO and NIO 2 and channels would be cool.
Yeah.
Thank you a lot, and see you next time.
Many thanks, Adam. See you.